Today we're going to learn about piecewise functions, two or more expressions that define different intervals of the functions. So as we've learned so far, functions have been described to have one expression, so f of x being equal to just x. Here we see that there's two expressions, f of x is equal to this first part, or f of x is equal to the second part here. So how would we graph this type of function? Well, let's create a table for each expression. So the first one, we have some input of x is equal to f of x is equal to 2x. So that's going to be the first one here. Now the values of x has to be greater than 1. So we can only input 2, 3, 4, etc. So when x is 2, 2x is equal to 4. When x is 3, 2x is equal to 6, 8. Now the graph here, we're going to go up by 2. So at 2, we're going to have 4. At 3, we're going to have 6. At 4, we're going to have 8. So this part of the function is going to look like this. Now let's tackle the second expression. We have x, and we have f of x is equal to x plus 2. And the constraint is x being less than 1. So x can be 1, 0, negative 1. Let's do those three first. 1 is going to be x plus 2, which is 3. 0 is going to be x plus 2, which is 2. Negative 1 is going to be 1. So when x is 1, f of x is 3. When x is 0, f of x is 2. And when x is negative 1, f of x is 1. So we see that this piecewise function looks like this. Now there's one important thing to note. For the first expression, it's if x is greater than 1. So it can still be 1.1 or 1.2. So we can actually plug in 1 for x here. So we'll plug in 1 and we get 2. And so it would be right here. However, we're going to have an open circle, meaning that it doesn't count the value of 1 exactly because it has to be greater than 1. So we denote it as an open circle. So what this means is that the symbols greater than or less than are going to have an open circle, while the symbols greater than or equal to or less than or equal to are going to have a closed circle. Now let's try this second problem. We have three expressions, so let's start creating the table. We have x, and instead of f of x, I'm just going to write 3x to save space. Because x is less than or equal to 1, it's going to be either 1, 0, or negative 1, to which we're going to get 3, 0, or negative 3. So this function is going to look like that. Then we have x, and we have 2x. This is if x is greater than 1 or less than 3. So we're going to have 1, 2, and 3. So this would be 2, this would be 4, and this would be 6. And lastly, we have x, and we have x. This is if x is greater than 3 but less or equal to 5. So we're going to have 3, 4, and 5, which we get 3, 4, and 5. Now notice that the second and third expressions don't have arrows extending infinitely outwards. This is because they're both constrained from 1 to 3 and 3 to 5. Only the first one is not constrained, as in x can be less than 1 and go infinitely downwards that way.